I am Anil Kumar. Welcome to my YouTube channel and the website globalmathinstitute.com. In this particular video, we are going to discuss moment of force on rigid body. A test question is being provided by my student Amy. Let us see, how do we solve such a question? If you really want to learn from me, you can always send an email on the address given here. I can conduct Zoom classes just as I am doing with my student Amy. The question here is, a rod AB of length 3A and weight W rests on a peg at C as shown in the figure. The end A of the rod rests on the rough horizontal ground, making an angle of theta with the ground. So this is the rod AB, which is resting on the ground at an angle of theta. The length of the rod is 3A from A to B, and C is the peg which is supporting it at this particular point. So that is what is given to us. Part A of the question is, find the normal reaction on the rod at A if AC is 2A. So if from A to C, this distance is 2A, find the reaction at A. Part B is, find the coefficient of friction between the rod and the ground if cos theta is 2 over 3 when the rod is at limiting equilibrium. So just about to slide. So at that point, we have to find the coefficient of friction between the rod and the ground. So I hope the question is absolutely clear. Try to attempt this question and then look into my solution. So first, let us try to understand this strategy, right? So the idea is to understand this strategy. And then I'll provide you with complete solution. So we want to find the normal reaction on the rod at A if AC is 2A. So we are given this is 2A. Normal reaction at A. What does it really means? So normal reaction will be at A. That is the normal reaction. Let me call this as R. This is what you want to find in part A of this particular question. How do we find this? Well, as we do with most of the questions related to moments on rigid bodies, we have to resolve the forces and then work on it. So basically, we have to do vertical forces. Their sum has to be zero. So vertical forces, one of them is given to us, is the reaction itself, which we need to find out. Now, at this point C, how is the force acting? That is the support. So at this point C, it has to be normal to the rod, and this force will be kind of like this. Let's call this force as F. Now the force here, which is F, can be resolved in vertical and horizontal directions. So this force F can be resolved in a vertical direction and the horizontal direction. So let's say that is the vertical direction and this is the horizontal direction of this particular force. If the angle theta is right there, in that case, which angle is theta here? Well, this angle here is theta, correct? So this is the angle theta for us. Now, many students find it difficult to figure out how that is theta, right? So let me show you that part also. So if I draw a horizontal line here, in that case, angle theta is this angle, correct? So you can see that in between it is 90 minus theta, and that is the right angle. So if that is the right angle, in that case, 90 minus theta is this. Let me write down. Here we have 90 minus theta. Is that okay? So if we are looking into this angle, which is 90 degrees, the other angle becomes theta. So that is how we can see that these two angles are equal. So in this particular case, you can see that the vertical force, let's say F of y, is basically equals to the cosine value of F, right? So it is F of cos theta. And the horizontal force, let me write here, F of x, in this case will be F of sine theta, because that becomes the opposite side with the angle theta. So these are the forces which are acting because of the peg right there. You get the idea, right? So clearly what we could do is we could resolve the vertical and the horizontal forces at C. So we get our components. Now the third force which is acting on this is the weight itself. Weight, since it is a uniform, we'll assume this to be a uniform rod AB. Weight will be midway of the whole length 3A. That is 1.5, correct? So let me just draw the weight here, which will be, let's say, here, like this, correct? So that is the weight which is acting, and this will be at a place which is half of 3, which is 1.5A, right? So that is the direction of the weight, and that is the force. Now, if you take the moments, vertical moments, then in that case, we know the upward forces are R plus F of y, which is F cos theta. That should be equal to the weight, which is the downward force. So this gives you a relation between R and W, right? We need to find the reaction. We can rearrange this equation and then we can use it, correct? So clearly, R is equals to W minus F cos theta. So that gives you one relation. Now the other thing is we need to work on the moments. Now moments can be taken at any point you want. So since the reaction is not known to us, it is best to find moments about A. So we'll take moments about A, right? Since it is in equilibrium, all the sum of the moments clockwise should be equal to the counterclockwise. So the clockwise moments are due to what? One weight, right? So this weight is giving us the clockwise moment. So clockwise moment is weight times the distance. So the distance is this distance, right? That distance, which is 1.5a cos of theta, right? The horizontal distance between A and where the weight will be acting. So it will be 1.5 A cos of theta. Is that clear to you? So that is the moment which is clockwise for us. Now the counterclockwise moment will be, we can have this distance which is vertical, right? Vertical distance is what? So you can find the vertical distance or you can use the value F itself, the whole force, and the distance here is given to us that the peg is 2a distance away. So F times 2a. So this force will give you a counterclockwise moment. So equating these moments, and now we can substitute the value of F and find R in terms of the weight. You get the idea. So we get our equation in terms of the weight by substituting the value for F here or eliminating F from these equations. Is that clear to you? Perfect. So that is how we are going to solve for the reaction. So that is the first part. I hope you have understood. So we have two equations to work with. Let me call this as my first equation and that as my second equation. So we've done the first part using the concept of vertical resolution of forces and second, the moments about A, right? Now let's see how do we solve the second part? So my idea is to discuss with you the strategy, and then I'd like you to answer this question yourself. So I hope from here you get the value of the normal reaction R, right? So use these two equations to find R. That is the whole idea, right? So you have F as 1.5 times WA cos theta divided by 2A, correct? You can substitute this value here. Substituting this, half of this, substitute here, find R, correct? So you have your equation, let me write down. So from here, we do get the value of R, which could be equals to R equals to W minus, instead of F, I'm writing this value, which is 1.5 W cos theta divided by 2. So that gives you the value of R, which you can calculate, simplify, get your answer. So that is one part of it. Now the second part is, let's look into part B, which is find the coefficient of friction between the rod and the ground if cos theta is given to us as 2 by 3 when the rod is at limiting equilibrium. So we're given the value cos theta equals to 2 by 3 when the rod is at limiting equilibrium. That means just about to slide. Now at that point, when it is just about to slide, the frictional force is going to be mu times R, correct? So at this particular moment, the friction force is mu times R. Now this frictional force mu R. So we're doing part B now. The friction force mu times R should be equal to what? The horizontal force here, which is trying to stop it, correct? So there's horizontal force, which is F of sine theta, which is trying to stop it. So it is equals to F of sine theta, correct? You know what F is? The value of F is given to us in terms of W. We know what R is, which is also given to us in terms of W, correct? Now here we are given additional information, and that is that cos theta is 2 by 3. So if cos theta is 2 by 3, you find what sine theta is. And therefore, all the things are known to you. Now the easiest way to find sine theta from cos theta is what? Well, make a triangle. So we have cos theta as 2 by 3. So let us say this is our triangle, which is the right angle triangle for us. That is the angle theta, 2 by 3. So that is the cos theta value. And this will be what? So this side will be 3 square minus 2 square square root, which is 9 minus 4 square root, or it equals to square root of 5. So this side is square root of 5. And therefore, sine theta is square root 5 over 3. Is that clear to you? So we now know the value of sine theta also. And therefore, we can find what mu is. R is known to us. F we can substitute in terms of W. Many terms will get cancelled, and you'll find sine theta is square root 5 over 3, and you'll get your answer. So I hope this strategy is absolutely clear. Perfect. Do you understand this part, right? Now, I would like you to pause the video and answer this particular question. We'll actually now discuss the solution of this question in parts. We are going slow because this is a very important concept, and understanding concept is more important than just the solution. Okay? Now here, let's get to the working for part A. So as discussed, what I've done here is resolve the forces at C. The force F is now resolved into F of cos theta and F of sine theta, theta being the angle which the rod makes with the horizontal. Perfect. So these vertical and horizontal forces represent F as such. The point F is 2a distance away from A, right? That is given to us. So this distance is 2A for us. Okay. And weight is acting at 1.5 A away. So, as discussed, the vertical forces, which are R and F cos theta, will match the weight. So, these are vertical components. So, when you equate them, we get F times, this is vertical, and these are the moments, right, at A. So, we are checking the moments at A. Because of the force F, the distance is 2A. We know this distance is 2A, and the moment is basically, in this particular case, counterclockwise. And this is equal to the clockwise moment because of the weight. Now, weight is acting at this distance, correct? So that is 1.5 A cos theta, right? So this distance is 1.5 A cos theta. So equate these two, we get actually two equations. So from here, isolate F. So dividing by 2A, A and A cancel. We get 3 over 4 W cos theta, because 1.5 is 3 over 2, right? And so we get F as 3 by 4 W cos theta. Now substituting this value of F in the equation, we can write what R is, right? So coming back from here, we know R is W minus F cos theta, and substituting the value of F, which is 3 by 4 W cos theta, we get 3 by 4 W cos square theta multiplied by cos theta, correct? And now taking common factor, we can take out W over 4 and get 4 minus 3 cos square theta as our value for the reaction R at A. So that is the solution for part A. Is that clear to you? Correct? So here we have reaction formula R. We have the value of F, which is in terms of W and cos theta. Now we can do part B. In part B, we are given the value of cos theta, right? So we'll attempt part B, where we are saying, well, cos theta is given to us as 2 by 3. And that implies that sine theta, as we worked out, is square root 5 over 3, right? Using this particular triangle. Perfect. And the horizontal component will be F sine theta, which will act against the movement mu r, right? So that is the sliding force. So now let's see how to do part B. So in part B, find the coefficient of friction between the rod and the ground if cos theta is 2 over 3 when the rod is at limiting equilibrium. So let this coefficient of friction be mu. So we'll now find mu. So mu r should be equal to F sine theta. So those are the horizontal forces acting. So now you equate horizontal forces. The only force which is stopping this from sliding is F sine theta. So therefore, mu r is equal to F sine theta, correct? So we know that, and from here we can find what mu is. We have already derived that r is W over 4 F minus 3 cos square theta. We know now that cos theta is 2 over 3, and from here we can write what sine theta is. Sine theta is square root 5 over 3. And we know F is 3 over 4 W cos theta. Now we can substitute all these values here. So the value of R, let's find R when cos theta is 2 over 3. So let's work out what R is. So R basically will be equals to W by 4 times 4 minus 3, 2 square over 3 square, right? So it is 2 over 3 whole square. So that gives you W over 4 times 4 minus what? So this is 4 square 2 square is 4 and 3 is 9. So it is 3 times 4 times over 3 square, correct? So that can be simplified and written as what? Let's write down R as equal to, when you open this bracket, this is 4, sorry. When you open the bracket, 4 and 4 cancel, we get W here. And in this case, that 3 cancels, 4 cancels with this. And so we get 1 over 3W, right? Minus 1 over 3W. So that means R is equal to 3 minus 1 or 2 by 3W, correct? So we get the value of R as 2 by 3W. Similarly, you can calculate what F is, right? So let's calculate what F is. F equals to 3 by 4 W times cos theta is given to us as 2 by 3. So now that is equals to W by 2, correct? So we know F is W by 2. Now substituting these values here, we can easily calculate what mu, the coefficient of friction, is. So mu times R, which is 2 by 3W, equals to F, which is W by 2, sine theta is equals to square root 5 over 3. So that gives us the value of mu, which is, we can just cancel W's here. And so we get our answer, mu is equal to what? So that 3 and 3 cancels, correct? So we get square root 5 over 4 as the answer to this particular question. Do you understand how easily we could actually figure out? It's not an easy question, but if you understand the strategy, then it is simple. So here is the complete solution for you, exactly what I did. So we knew that R was W over 4 times 4 minus 3 cos square theta. We worked out in part A, right? So this was part A. We got this. Cos theta is given to us, so we found what sine theta is. And this is also from part A, that F is 3 by 4 W cos theta. Substituted cos theta value, which is 2 over 3, and found it is half of weight. R also, we substitute 2 by 3 and found it is 2 by 3 of W. The basic equation on which we are working is mu R is equal to the F sine theta. So horizontal forces have to be equated, right? That gives you the equilibrium, right? So the static friction is just at cos theta equals to 2 over 3. That is very critical point. So at this point, it is still at equilibrium. So we'll equate these and find the value of mu as shown here. You understand the concept, right? So that is how we actually find the solution of this particular question. So I hope the approach is clear to you, the strategy is clear to you, and I hope with this you can solve similar questions very easily. Now, in case you really want to learn from me, you can always send an email on the address given. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.